We have this time a panel on inventors, patents, and IPR. It's also a new topic, of course, inspired by Zvi. We have 3 presentations, 20 minutes for each presentation. Kevin, Bryan, you start by the paper trail of knowledge revisited. Obviously, something that would be at the heart of what Zvi would like to hear about. Kevin, the floor is yours.
All right, very good. And I can't quite pull off the full Philippe Aghion presentation style, but I'll keep it energetic enough because it's the start of the afternoon. This paper, everyone here I think knows Griliches 79. But if you look into this kind of classic paper, we're trying to get at the social return to R&D. And so Griliches, most people think of this paper as like a production function R&D paper. But you'll see basically what he says is that at the micro level, we can only ask questions about private returns to R&D. Very little of those social returns is even detectable. And if you wanted to know what the social return was, if you look here at the bottom, we can't use this production function framework. We need basically confidential private information, which is difficult to reproduce, extend, and evaluate. So for me, the most important question in all of innovation economics is what's the social return to various types of innovation? It's a very, very hard thing to measure in general. And one of the main reasons it's hard to measure is that it's very difficult to get large-scale data on the extent of spillovers to understand how they work. So I'm going to show you some survey results today, but also an econometric technique that basically is going to allow us to solve this problem, which is that even when we use surveys, the data is just too small to do interesting econometrics with. So we're going to solve that problem. This is the kind of one to have in your mind if you don't know this quote, is that there's no paper trail of knowledge. Of course, until some of the work that Adam and Manuel and some of the other folks started doing, which was we can try to measure these spillovers, try to measure these public returns by drawing on links within patents, okay? So patents cite each other. It looks something like this. I know some people here, we were told, throw a mention to Griliches if you can during your talk, but I went above and beyond that. Griliches is the data point in my paper. So if you note here, Zvi is quoted, and I think Bronwyn's also on here, and a few others, folks who are probably here make an appearance as well. So yeah, there you go. I see, there's Bronwyn. So basically what we have here are on the left, these are so-called in-text patent citations. There's a ton of these that I started collating a number of years ago. Now Matt Marks and Fugi and a few other people have extended into really nice data sets. These front page citations, these are what you would know from the early 90s MBER data set. Really well standardized now in PatStat and other measures. So we have basically references in patents to prior documents, including patents, academic papers, newspaper articles, and all sorts of things. And now these are standardized and really easy to use going back to the early 1800s even, actually, in the case of in-text citations. Problem is, it's very difficult to know how we're supposed to interpret these. Like this list right here, like all due respect to our friend Zvi, but I feel pretty certain that this patent does not rely critically on Zvi Griliches' 1987 handbook chapter here. And all respect to Bronwyn, but I don't think that this paper is like the critical thing making this patent happen. And we often worry that citations vary massively in their quality. And we also worry that they vary massively in how they're used. So what we want to do is we want to figure out just empirically what the heck do these things mean. And then for empirical use going forward, we want to figure out which of these things actually matter. What are the important citations and why? Like which of these citations led to the development of new inventions and which of them are basically throwaways. Okay? So that's what we're going to try to do today. I should mention, if you haven't used in-text citations, this comes from Marks and Fugi's website, Reliance on Science, where you can download some of this data. But basically, they grabbed like 32 million, or I don't know how many they have now, citations, and they showed the overlap between in-text citations and front page for academic references is like 13%. So like the vast majority only appear in one place. So the other thing we're going to try to figure out today is, why is that? It turns out that if you call a lawyer, a patent lawyer, and you ask them, why would these be different? Both Matt and myself have called patent lawyers, and they're like, what do you mean? We would put the same things in both places. And we're like, empirically, not even close to being true. And so we're going to answer that question as well today. So here's a quick roadmap. Large inventor survey, I believe the first large-scale survey ever on non-patent literature that'll show you some results on how people use these. Second, we're going to use some tricks from machine learning and the text that surrounds those in-text citations to basically extend the survey. So I mentioned to Dan Goroff earlier that so Sloan Foundation paid for this survey, at least in part. And I mentioned I'll show you guys that basically I'm gonna save Sloan a few $1 million on their next grant by using technique number 2. And if you guys use this for your own papers, there's a number of other use cases you can save your funder some money as well. And then the third thing is once we understand why these sites are being used, and we extend the survey to get a sample size that's an effective sample size after controlling for measurement error in the hundreds of thousands instead of like in the 1,000 range, then we can start to do interesting econometrics on interaction terms, and we can answer questions, for example, does the recombination of science generally involve a tool from field A combined with background knowledge from field B? Is the rate of diffusion over time and over space differing for different types of citations depending on how they're used in a patent and so on? So we'll be able to answer those questions as well. All right, so let's start with a survey. So we contacted 10,000 inventors. I'll tell you why 10,000 in a second. And we asked them a series of questions, trying to keep it short enough they would actually respond to the survey. You'll probably recognize, like Adam, you'll recognize some of these are from the your paper with Manuel and Fogarty. So we just use the exact same language to make it comparable. This last one, how important was your citation to the invention? We took from a paper by Mansfield in the 90s as well. So what we're going to do is we're going to send an inventor a piece of paper. It's going to list, you cited this article in this patent. Like, how important was it? When did you learn it? Why did you cite it? And so on, okay? So how do we get 10,000? So in a 16-month period, when we ran this survey, there was 451,000 US patents. Of those, 170,000 had a European family, which is useful because the EPO has individual inventor addresses in their database, and at the time, at least, US patent records didn't. So of those 170,000, 20,000 of them had either a front page or an in-text site to an academic article in a set of 248 journals. So we did this before Matt and his co-author extended this data set. And so these were the only ones where we'd extracted in-text citations at the time. But it's like all the famous journals in engineering and biotech and medicine. So 20 over 170 is something like 12%. And overall, it's about 32% of papers cite science somewhere in them. And so this is, that 248 journal sample actually captures a lot of the citations. Of those 20,519, we can only ask a single inventor a question one time. And we don't want to ask people about the same citation multiple times, even if there's multiple inventors on the patent. And so that means like we can't actually ask about 20,519 of these. We can ask about many fewer. And so essentially 10,000 is more or less the universe of citations we could extract over the 16-month period. So we can't do more. Of those, slightly more front page than in text. I won't get into why. So mailing out a survey, even if you have someone's address from their patent, not so easy, because one, people move. Two, their address is often a corporate address, and it turns out when you send a survey asking people why did you cite something in a patent to their corporate address, you get a letter back from their lawyer saying stop emailing our people these surveys. And if you send it to their home address, sometimes they moved. In one case, we got a letter back saying the person is now in jail and can't answer your survey. So we put a lot of effort actually into updating current addresses and trying to find the most current address. We set up the survey so we had like multiple reminder postcards. This is also incentivized with Amazon gift cards. We managed to get the email addresses of 76% of the people in the survey and contact them that way as well. That was using like a bunch of money in Mechanical Turk. So in the end, we managed to get this to about 9,460 people. Of that, 1,536 responded, so 16%. Not that easy to get people to respond to surveys when you're asking them about like legally consequential things, so we were happy enough with 16%. What does this data look like? So column 1 in these is all the patents in our 16-month sample. Column 2 is the European cut. Column 3 is anything that cites science. And you'll see anything that cites science, the big difference is that it's much more likely to be medical and biotech related than patents overall, unsurprisingly. And it also has many more forward and backward citations, actually. So these are relatively high quality patents, a little bit because of the necessity of we needed someone's address, so it had to have at least a family size of 2, so we get the European one. And then the biotech sample is just because that's where people are citing non-patent literature in them. But you see, once we get to that 20,000, it's like basically identical statistically, the sample we actually contact and the sample we hear from to the overall sample of science citing patents. All right, so let me give you some results from the paper. So here I'm going to split the sample into why did you cite this particular piece of science. So let's split it into was a tool or technique that I used to develop my invention. It was general background knowledge on the field of the invention, and then it was like an unsolved problem or a use case for my invention. And these 3 bars, the black bar is I knew about this thing before I made my invention. Gray is I knew about it or learned about it during the process of making the invention. Light gray is I didn't even know about this until after I made the invention. So you'll note, first of all, things I knew about before I made the invention is like a third of these citations. And another third of them were not known until after I made the invention overall. I see Adam nodding because he's probably thinking like, when you ask about patent to patent front page citations, it's like 60% of them weren't known until after the patent was granted. I think you have a line something like, it's the glass half full version. This is the half empty part of the glass half full. Like there's no way this is knowledge transferred to an inventor because the inventor didn't even know about it. So that's true even for NPL sites. About a third of them are not known. But the interesting thing here is that it varies a ton for why you used it. So these tools and techniques are like 25%, so like 8 percentage points more likely to have been known before the inventor started making the invention, and about 8 percentage points or 25% less likely to not be known at all until after. So in some sense, I think of these as like relatively high quality sources of spillovers compared to the average site. And I should say actually, all of these are higher than the 4th category I'm not showing you, which is I don't know what this is, which is 13% of the citations. Those ones, like 90-something%, I'd never heard of them until you sent me the survey, okay? So even these are a little bit higher than some of the others. All right, how did I learn about it? So we're going to, we asked people on both, black is in text, gray is front page. How did you learn about this thing that you're citing, this non-patent literature? And what you find is about half, slightly more for the in-text citations, were known about through some type of direct contact. Either I read the paper that I'm citing, or I saw it demonstrated, or I had word of mouth or direct communication with the person who wrote it, okay? So that seems reasonably high. If you look at the I wrote or co-inventor wrote, that's something like 7% for in-text citations, 9% for front page. When Matt Marks looked at this, just trying to do name matching, he found 6% and 10%. So at least the survey is somewhat consistent with what you find in the raw data there. And again, in the 2000 paper on patent front page sites, so sites from a patent to another patent, only 36% of the stuff was known through either reading or direct contact. So again, maybe another reason to believe these non-patent literature citations are overall higher quality, especially the in-text ones, than patent-to-patent sites. And I think theoretically this makes sense. Like the patent sites are often added by your lawyer, and it's just unlikely your lawyer knows some of the stuff you're citing is like tools when you're describing how you're creating your invention. Okay, so this is on a Likert scale. So we asked people, how important was it to your invention? From 1 to 5, the thing you're citing. How familiar are you with it? How related is it to your invention? Okay, again, black is going to be in text, gray is front page. You'll note there's essentially no difference between these, except that the front page citation is actually more related to the invention, which again is consistent theoretically with what you would expect. Literally, you're obligated legally to put things that might read on your claims onto the front page of your patent as prior art. You are not obligated to put related things in the text of your patent. So it's not that surprising we see this difference. That said, I think this should make you a little bit worried about what we're doing when we're treating citations all equally, because most of them are incredibly unimportant. So 1 or 2 out of 5 on the scale, how important was this to you making the invention? That's 69% of both in-text and front-page citations. 13% of them, so very few, are a 4 or a 5. We really want to be able to identify those. Actually, this is lower than what Misha Teplitsky and friends found for academic citations. So a citation in a patent is seen by the inventor as less important than the average citation in an academic paper to another academic paper. We all know about how important most of those are. If you look at relatedness over here, again, in line with theory, slightly higher for front page citations. Even there, though, only like 21% of the front page citations are considered like very related to the invention by the inventor. The interesting thing about this, by the way, is that they all say this, even though it's not that they're not familiar. Like, you might think, well, I have multiple inventors, maybe I just don't know what this citation is. But only about 20% of the citations does the person say, I'm not familiar with this site. So 80% of them, the inventor we surveyed was familiar with the reference, and nonetheless they said not really related, not really important in many cases. All right, so let's look at different reasons you might cite a patent. So again, tool, background, unsolved problem or use case, or I don't know, by whether it appears in text or on the front page. So remember I showed you tools and techniques. I have pretty good reason, both theoretically and here in the survey, to believe those are more important citations. Thank you. And actually, tools and techniques are 42% more likely to appear on the front page, appear in text than on the front page. It's like 4.1 percentage points. It's like 14% versus 10%, basically. So you're unsurprisingly more likely to find the tools you use to develop your invention in the text. So if you want that particular type of reference, you better be looking in the text of patents. And I should also mention, a lot of people use abstract similarity to look for antecedents to invention, but you're never going to find the tools you use to invent something with this method. So actually, I don't know of any other way to find, other than like reading the documents that people wrote about how they invented something, to know what tools they use. Even we don't cite, I use Microsoft Copilot and then I use Stata. Like, we don't do that either. Okay. So now let's try to dig into how we can use this survey in a useful way, because though I have those stylized facts, 1,500 survey responses, maybe 1,300 of them are complete, so about half are front page and in-text. We cut the sample down to 650. You're kind of limited in what kind of econometrics you can do there. But we have all this writing right here. So even though that survey cost us like $27 per complete response, and I surveyed the universe of people I could get the address for and try to contact over 16 months, I can't survey someone from 1970 at any cost. It costs infinity. Okay, so how can I know why, like in this patent right here, people were cited, like, for example, like, this is actually a total coincidence. I didn't know Jim was talking at lunch. Like, why Jim Heckman is cited here in this patent. So the thing is, you can read this, and it says, past empirical work has tended to show that civil rights laws and EOC have improved economic conditions for protected groups. And I ask you, why was this cited? Some kind of a motivation for the invention. Right? You can read the title, Method and System for Reversing Induced Discrimination. You can read this text, and you as a person know this is likely to be a motivation for the invention. If I had asked you of those categories I showed you before. Likewise, I can show you like this one, and I say, these cells were prepared using methods of Titus, and the incubation was carried out, so it's some kind of a tool or technique used in the invention. And I show you this one, additional descriptions for applications. That's some kind of similar invention or a use case. Show you this one, the pancreas 1A PTF1 plays critical roles in formation and spatial organization of the murine exocrine, some kind of background knowledge. Okay, so you can read a lot of these, and you would be able to guess what they are. So here's what we're going to do. We're going to take the survey responses as ground truth. We're going to use originally convolutional neural nets, but actually it turns out to work better using large language models now to predict the other millions of citations, why they're being used. And then we're going to adjust our standard errors for the measurement error, which we know because we know the ground truth, how much it matches. And then we can do some good econometrics on a sample size that's effectively in the hundreds of thousands instead of in the area of 1,000. So originally, embedding plus CNN, it worked okay, not that good. We put this paper on ice for a few years while we waited for computer scientists to catch up for what we need to do. They finally caught up for what we need to do thanks to transformers, LLMs. And so basically, the way LLMs are useful for this are that the LLM is trained on like billions of texts to understand the relationship between English words. So implicitly, the statistical power of our survey doesn't have to be used to understand like synonyms and all these other aspects of English language. It can be used just for our problem. That allows it to do a much better job at our prediction task. So unfortunately, our friend Zvi has also thought about this in his papers on errors and variables. And when you create a proxy variable, and so for instance, if my dependent variable is a proxy measured with error, and it's not classical measurement error, so it's not mean zero with a nice symmetric distribution around it. It turns out it ruins like all sorts of statistical estimation. It's really, really hard to use this. I think he says here, talking about Schultz and who we've already met today, and Irving Fisher, that I wish to dedicate this lecture to the memory of Ragnar Frisch, who saw clearly the problems and worked on this solution, but even he abandoned it. And all these other guys, Frisch and Schultz, they looked the evil of this problem squarely in the eye and moved on, right? So it's not an easy problem to solve. That said, luckily, our friends Jerry Hausman and Fiona Scott Morton and other folks have shown for probit models with the exact type of error and variables we have. It turns out I won't show you the match for reasons of time. We can move through things. Basically, we get to this point where what I need to do is if the probability I misclassify, like I say it's a tool when it's actually not a tool, or I say it's not a tool when it's actually a tool, call those P and Q, just raise the sample size by 1 over P plus Q minus 1 squared, and that basically tells you how much worse your variance is going to be. Okay? So this tells you how much larger of a sample size you're going to need in order to do the same statistical inference. So what are P and what are Q in this situation? Really hard because even the survey has errors. So here they say, it's been determined that short telomeres are a signature, give me 1 minute, I'll finish up, are a signature of idiopathic pulmonary fibrosis and ... I mean, this is some kind of motivation or background knowledge, but the person we asked about this in a survey said it was a tool or technique used in their invention. So there's no way the computer's going to figure that out because the survey response is just wrong. Nonetheless, we run this through an LLM that's pretty advanced using some nice tricks, and we find on a base rate of 17% tools, 41% of them are true. When the survey says it's a tool, I get them 41% of the time. When it says it's a background knowledge, I get that 88% of the time. So P plus Q minus 1 squared turns out to be 12.1. So basically one survey response is the same, 12 survey responses is the same, one survey response is the same as 12 proxy responses, okay? So last slide here, what does that mean? Well, there's 2.5 million in-text citations in the last 5 years. It cost me 1 penny to create the proxy variable. 12 proxy responses is 1 real one. $25,000 what I spent on, actually less than I spent on the survey is 208,000 standard error adjusted survey responses. That would cost me $5.6 million to do in a survey, even if I could survey people from like 5-10 years ago and they weren't in jail. So I think this technique is actually useful for a lot more. I'm going to skip any discussion of what you can do with this just because we're out of time. But thank you very much, and I look forward to hearing from Fabiana as well.
Okay, here we are. So, I don't want to repeat what Kevin already well summarized, but I want just to stick the main point of the paper. So, knowledge flows are invisible, and they leave no paper trail by which they might be measured and tracked. And however, in our community, many of us use patent data, and in particular citation, to trace knowledge flow. And this work is an example of that. In particular, this work focuses on patent citation to scientific papers. And I think that this is a great job and a great idea because especially in our community, what we know is mainly published, so circulate through papers. So when you trace the citation to patent, in this way you are really tracing the link between science and innovation in a comprehensive way. And so the idea is to see what Inventors cites and why. And so you conduct a large survey, and what I like the most is that you really explore heterogeneity across citation. So why inventors are citing, how inventors are citing, so when they learn, they get to know the paper, and how the citation relate to the invention. And most importantly, you complement this with machine learning technique on the patent document to infer for unsurveyed patent why inventors cite academic papers. And doing that, you overcome some limitation that relate to large survey stuff. And in particular, the high cost, but not only the high cost, the impossibility to reach everyone. And this is the first work as a follow-up of Jaffe's work, where you are asking about in-text citation. Apart from the heterogeneity between front-page citation and in-text citation, what surprised me the most is the fact that there is really little overlap, 10%. So what I like the most in this work is the fact that is a really inspiring contribution on mapping the links between science and innovation. On the top of that, I like the idea of finding a tool that is replacing in a certain way surveys. So I think that is fascinating, the possibility to making prediction about unserved patents, and I think that this has great potential. It is an impressive work, and everyone can see that because it's a large survey, and you run the survey over 16 months, and there was a huge work in retrieving addresses, combining different data sources, and manual checks also. So here my food for thought. I think that there is a potential to explore heterogeneity because so far we have learned that in terms of frequency in the citation to science, clearly biopharma and chemistry cite more science than other fields. But are they citing also for different reasons, and how? So it can be that a more complex field, in more complex field, inventors have different motivation to cite. Maybe they have to give more background to make their innovation, their invention accessible and replicable. And I think that there can be also heterogeneity along the stage of evolution of the field. Because if the field is at the early stage or in a topic that is in an early stage, the motivation for the citation can be different. Then I wonder if you have data to explore the heterogeneity on the side of the inventors. So I don't know if you have access also to inventor characteristics, because I think that it would be amazing to see if inventors of different age or of different gender behave different. And I think that this can be a paper per se. So, in my understanding, machine learning technique allow prediction for unsurveyed patent, but on the motivation for citing. I was wondering if it can be extended also to the other dimension. In particular, on how the citation relate to the patent. And here, one possible suggestion that I don't know if can be applied is to use natural language processes to compute the similarity between the patent document and the title of the reference to see how the citation relates to the patent content. Possible application. Again, I think that your tools have great potential. In particular, in linking, I think that this is an inspiring work in exploring the linkage between science and innovation. And I wonder, I think that one important question to answer and to think about is if the relationship between science and innovation change along the technological trajectory evolution. Tomorrow, I will present a paper with Reinhilde and Michele Pezzoni, where we trace novel technological trajectory, basically linking together patent that combine the same technological component. And I think that it would be interesting having this technological trajectory to see what these patents are citing along the evolution of the trajectory. So it might be the case that citation in the takeoff phase are different than citation in the maturity phase. And another possible application, I saw that in your presentation you mentioned also some work that consider citation in science. So basically science to science citation. I was wondering if this work can be extended to science citation. In the sense, it would be important to understand on which knowledge we build upon, and why are we citing and where. And here, thinking about a parallel between a patent and a paper, I was wondering if we can see the introduction of a paper as a front page of a patent. Because maybe what we cite in the introduction section can be different from what we cite in the rest of the corpus of the paper. Because it can be that we cite to attract the attention of an editor, it can be that we cite to address the editor to specific reviewers, and so on and so forth. Minor comment, and then I will close. It's not clear to me if you are filtering the solo inventor patents, and if not, how you deal with patents where there is a team of inventors. Then a real minor issue, curiosity. In the question, how did inventors learn about cited science, one of the answers, that I think is 10% of the cases, inventors learned from the survey. So, how is it possible that they realize, they get aware of the citation only when you ask about that? And now I'm closing, and thank you so much for the inspiring reading.
Okay, thank you very much. Replying.
Sure, let me
okay?
just give 30 seconds for Fabiana. Will you grab the hands? Yeah, thank you so much. Really interesting. There are many multi-inventor patents. You obviously might worry this would attenuate because a given inventor might not know everything in the patent. But the familiarity question makes me confident that actually they generally do know. And your use cases are actually super great ideas. Predicting importance is not that easy just using text. It turns out that in academic papers, it works a little better. I'm doing some kind of preliminary stuff with Marlene Kofi, my colleague, on exactly this problem. Because basically finding the citations that actually mattered is much more useful for all sorts of research, because most references everywhere are just garbage, not important. And so we need some way to filter them out in a better way than we do now.